Sure I did. Okay, so I've already introduced myself to most of you guys. You guys saw this, so we can promptly move on. Canvas, right? It may be kind of weird, but I do have, by far, a favorite HTML tag. I really do. You may like the H1 tag. It's very loud. Big. Marquee is fantastic. Blink is questionable support these days. I love Canvas. Love Canvas. Absolutely Canvas. By far my favorite HTML tag. So Canvas is a part of HTML5, which is kind of funny because there's actually practically no HTML involved in doing programming for Canvas. Because you basically put a canvas on the screen and then do JavaScript the entire rest of the time, and just the canvas is just sitting there and you're doing stuff on it. Okay? So it's HTML5, but like many features for HTML5, that's just another way of saying browser capabilities that are driven by JavaScript. And Canvas is one of those. If you want to do anything, literally anything with Canvas, you're going to be doing either a little or a whole lot of JavaScript. So I'm going to assume at least a basic knowledge of some C-based language, because JavaScript is what you're going to be using. If you've done any JavaScript, then everything we're doing here should be just totally fine. Won't be using any libraries. There are no plugins involved. This is just JavaScript and the Canvas element. So what we're going to do is we're going to start by we're going to walk through the API. What's some of the kind of stuff that you can do with Canvas, and then I want to start talking about some techniques and show you one app, and then show you a sample page to show you just some of the things you can do with Canvas. At first, you may think, oh well, what is Canvas? Well, it's an element you can put on a page and you draw stuff. What can you do with an element that you put on a page and you draw stuff? Well, you can have all sorts of applications. You can have games, which is more often what I actually want to be doing with Canvas. This is one of them. NodeKick. I like Node, and every year there is a Node knockout. I have a team. We build a game every year, and this one was last time. Dive Kick game for the PlayStation. It wasn't all. Oh, you killed me. Thank you. Okay. Okay, so anyway, it's a PlayStation-based game. We decided to make a canvas-based. This is one large canvas, all right? And this is a sprite we're doing around, and all the communication is done through WebSockets. So that's a game. There's lots of practical applications, and we'll get to it. Okay. First, I want to talk about the basic API, how Canvas essentially works, and start building some little bit stuff and see some of those characteristics. All right, so let's look at the code. All right, there's my index page. All right, this is that page. All right, here's a Canvas element, width 500, height 500. Probably can't see that line very well, so let's give it a border. All right, that's my canvas. This element right there. Okay. Like I said, without JavaScript, you can't do anything with this. So let's start messing around with it. First thing we need to do is we need to get that element, right? So I'm going to get the canvas. All right, what's it called? The canvas. There can only be one canvas. All right, that's not true. You can have all sorts of canvases, and there will be many times in your applications, I've especially seen this in games, where you'll need it's useful to have a number of canvases on the screen. All right, so canvas. What is canvas? You can think of canvas like a painting canvas. Okay, it's a flat thing that you draw stuff on. Okay, however you want to look at it. Okay. Now, if you're going to have a canvas and when you want to do something with that canvas, you need a brush. Okay? In Canvas HTML5 lingo, they call that a context. And I'm going to call this just C, all right? Because throughout this presentation, you will see several hundred instances of C, of this variable, all right? Because we use this for literally everything we do to the canvas. And so I'm just going to call it C to save on thousands of letters typed, all right? So we can say canvas dot get context to D. All right. So let's look and see what we're looking at here. Canvas. Let's see. Let's launch that guy. Sweet. I'm just going to go full page. Okay. So let's reload this. What do we have? Well, first of all was the canvas tag that we consoled out. At the very bottom, you've got a canvas rendering it context to D. All right. This context is your brush. If you would find it useful in your own code, you could just name it brush. All right. If you want to do anything, you're going to use that. So let's do something very, very basic. Let's draw a line. Okay. Now the way lines work in Canvas, lines are what are called paths. So I can say, see, remember this is my brush. I want to begin a path, all right? I want to move to a location. 100, 100, all right? Canvas works on Cartesian coordinate system. This is 0, 0, x as it increases goes this way, y as it increases goes down that way, okay? So 100, 100 is going to be, ish. We'll find out exactly where it is. So we're going to move there. And then I want to draw a line. Okay? We've moved there. We're starting there. Let's go to 150, 150. All right? Diagonal line. Okay? Now we do this, we're not going to see anything, which is kind of disappointing. Why? Well, here's why. It's not really about lines themselves. It's about shapes. It's about paths. Now, typically in paths, you're going to have two things to this path. There will be both stroke and there will be both fill. I've told it to neither stroke nor fill. All right, so let's do that. Okay, so there's a line. All right. Now, if I were to tell it to fill at this point, what would happen? Nothing. We need 3 points. Right? We need one more point for us to actually see any sort of fill. So let's do back to 200 and then 100. So let's go back up a little bit. Stroke. That. All right. So we have that. Let's tell it to fill. Nice little triangle here. Okay. Now you can control a number of things here. Like for example, we could say change our fill style. I could say c.fill style equals red. Okay. Stroke should stay default black. All right. So now we have a red fill and a black stroke. Okay. Cool. If I recall correctly, the width of the stroke is at that property. Yes, it is. Okay. So there you go. We've now drawn something. Okay? Amazing. We can draw triangles. Yeah, no. It's mind-blowing. You're welcome. Good night. Okay. Let's do a little bit more with this. How about, this is not good enough, we need circles now. Now, what you might think is, oh, well, there's line functions. Maybe there's a circle function. There's no circle. However, there's an arc. All right? So let's do this. And not that you would know this, but I just happen to know this is what parameters are. The first one is x. So let's go to 250. Second one, y, 250. Third one would be your radius. Okay? So let's give it a radius of 50. Next to, this is where the math gets fun. Okay. Next we're in radian world. I hate radians. Okay. Now some nice person gave me this diagram. All right. A circle has 2 pi radians. Okay? 3.14. There's two of those to make an entire circle. All right? So we can probably do this where if we start at 0 and we want to go all the way around, we can say 2 times math.pi, and then let's see what we get. Wrong way. This way. You know what I got to do? I got to store it, or I got to fill. One or the other. I'll just fill this time. Ah, there we go. Okay. Now, here's where I did something stupid.
Same path.
It's the same path. You begin a new path, and every time you do something along that path, which we will definitely use here in a minute, it will continue to use that path, and so we're just doing weird things. I don't have to end the previous path. All I have to do is begin a new one, and then we're golden. Okay, so we have our circle. So let's play with this radian thing a little bit. So we could say, you know, let's say 1, and then we could say 4. So we're going to see a funky looking circle here, all right? So the way this works is, by default, your circle, your arc, excuse me, is going to start right here. I started 1, so that starts there. And it's going to go clockwise, okay? I don't recall if the default for this is false or true. It is false. You can change the order to counterclockwise by passing in a last value into true. Okay? So that'll take it that other way. Now what I typically like to do, because I don't like radians at all, is you can do math.pi divided by 180 times whatever that number is, and that will convert it to what you normally think of like 360 degrees when you think of that. So I'm a math wimp, so I do this. I have a really hard time typing math now.
I do this too.
Now that I've worked at Match for 8 years. It's very difficult. Okay, so so this right here should give us a full circle. Okay, so then we can say, oh, I want to go to start at 45 degrees and go to 300 degrees and see what we're going to get. Okay, so of course counterclockwise, switch it back to false to go clockwise, and there you have your arc. Okay, so that's the arc. You can draw regular arcs, you can draw circles, you can draw funky things. So let's draw funky things. Keep going the wrong way. Okay, we don't need this line anymore. Let's get rid of it. All right, so let's do a little bit of animation. All right, this will help us see some really important things about how Canvas actually works. All right, so let's create an object. All right, I don't want random variables scattered everywhere. I want to create an object and just start putting things on it. All right, I'm going to give it an x of 50, and a y of 50, and a radius 50. All right, and then I'm going to take this right here. So let's start moving to this little object structure. So let's say thing.x, thing.y, thing.radius. All right, and let's get back to our normal circle here. And let's make sure nothing's broken. Okay, good. Now I got rid of the earlier fill style setting, so therefore it switches to its default black. That's where we get there. Okay, so now let's animate. So what we need to do, if you want to animate something like this, we want to animate this thing, and I want to animate it across the screen. Okay? What I need to do is, over time, increase the x value of thing, right? And then just keep redrawing it, and it'll move across the screen, right? Now, the way you typically want to do things with Canvas is you don't want to do like a set interval to control how many times you write to the screen and whatnot. That's not generally what you want to do. When you're talking about rendering to the screen, what you generally want to do is use something that the browsers supply for you, at least in modern, recent browsers. And And so we're going to use that, all right? Because what that is it is a function that you essentially pass your own draw function to that is attuned to how often the browser wants to paint, all right? And so if you want to, for example, well, say it this way. The browser is going to try to paint at 60 frames a second, all right? And as long as what you can do in your own custom drawing can fit in 60 times a second, you're going to get fantastic canvas performance, all right? In a few minutes, we're going to do something that won't allow you to do that because it's cool. But that's essentially what you're wanting to do, okay? All right, so let's do that. Let's make one more change here. I like objects. Let's move all this in here. So now it's going to be this, and this, and this. All right, now this function I was just mentioning is called request animation frame, all right? We're going to create a function essentially for drawing, and this is going to be involved with any sort of drawing we want to do on the screen. In this case, we're just going to really have thing draw itself, all right? But that's what we want to do, all right? We want that to happen as much as we can, 60 frames a second is all possible. So we saw window.request animation frame, all right? We're going to pass in draw loop. Now the thing about request animation frame is it is recursive. So what you do is you get yourself in a nice loop. And just for fun, let's see what happens. Okay. So if you look at this tiny number, it's going up very fast. Okay? The reason why is the browser is trying to draw this thing at 60 frames a second. Now one thing that's nice, right now it's at like 790. If we switch and go to another screen, which is an awesome screen because it's node kick, and then we go back, it was still at 790 and then started moving up. If you use request animation frame for your rendering, the browsers are smart enough to know that if you have multiple tabs open and you switch to another tab, it's going to shut that thing down because you don't need to be rendering when the thing isn't showing. So for one thing, it's a browser performance thing. Okay? But the most important thing really is performance-wise, that's what the browser wants you to do to get your optimal performance. So when you want to do some canvas drawing, ultimately this is what you're always going to want to do. But now it's set up, I don't think we're really going to have to do much with it. Okay, so let's get back to animating. Okay. So let's do this. Let's say, just put this here, thing.x. Every time this runs, let's change x, all right? So what are we going to see here? Get it in your mind, what we're going to see, okay? Is that what you expected? No, okay. It totally makes sense. Let me explain why. Imagine you have a painting, okay? An actual physical painting. This whiteboard, all right? Look at painting. It's too old, whiteboards. I have a dot. On this whiteboard, I want to animate this dot across the screen over time. How do I do it? Erase it, draw it again. Erase it, draw it again over here. Okay? What I'm doing right now is we are continually painting on the screen the same circle, 3 pixels at a time. Okay? Because it's like a painting, it's like a whiteboard. When you draw pixels, you're just drawing pixels on that screen. So what you need to do anytime you want to animate something is you essentially need to invalidate the screen or clear the screen. So let's do that. Let's say there's a function for Canvas for you to do this. Okay. It's called clear rect. Okay. Clear meaning clear, wipe it free of any data. Okay. And rect, clear the rectangle. I want to start at 0, 0, and I want to do the whole canvas width and the canvas height. Okay? And now I have basic animation. Okay? So 60 times a second, it's wiping it out, drawing a circle slightly further over to the right. And that's how you get your animation. Okay? That's really all there is to the basics of canvas animation. Of course, it can get a lot fancier, and we'll do a little bit more. Eventually, I'll stop going the wrong way. All right, so let's do this. Let's play with this path some. So let's say 40, 20. Ooh, that's really wrong. All right, what are we going to have here? All right, this is not a very nice looking circle. However, if we then say, we take the line to this dot x and this dot y, this is going to be in the center of the circle, right? Oh yeah. Pac-Man. All right, that's cool. All right, so let's work on our Pac-Man stuff. Okay, so we're moving to the right. Let's just look at it again. I want Pac-Man to start going the other direction when you get over here. Okay, so what do I do? Okay. Well, if thing.x is greater than canvas dot width, I need to start going the other way. So I'm going to do this. I'm going to say direction, let's give it a positive integer. And I want to do a positive integer because I can say times this dot direction. Okay? So that all I got to do is say here, this dot direction equals -1. Okay? All right, so this should be slightly improved. Apparently I said something completely wrong. Thing.x
is it the 3 times the direction? The 3?
No, I want that.
Probably one thing instead of this. Shoot, this is probably going to be 3 times undefined.
No, it should not be this. Thank you. That's all it was. That totally makes sense. It nanned me. Thank you for your okay, so how are we doing? How are we doing?
I think you have one more this in there.
Did I have another this?
Yeah.
Okay, point out anytime I do that. Tell me I'm wrong. Okay. Now is this going to do what we want? Almost. Very close. Oh, snap. It is off the screen again. Let's do something about that. So then, else if thing dot x is less than 0, what are we going to do? Thing dot direction equals. So we should have now a Pac-Man that does not close his mouth, that bounces back and forth. Okay. I think we can make this slightly better. So, as you can see, he's partially going off the canvas. This is easy to fix, right? So we can say canvas width minus its radius. Right? Radius is 50, so it's going to its origin point. And I'm going to check in all this stuff into GitHub later. So this, what we have here, we'll make it up to GitHub. Here it's if x is less than this dot radius. Maybe I should move this into the draw method just so I'll stop doing that. Okay. Boom. Oh, that's much better. All right, so we have Pac-Man walking across the screen. All right, now what we want to do is we want to make his mouth move, open, shut. All right, so the angle part of this is this, right? These bits. So essentially, we want to animate these two numbers. Okay? That's what we want to animate, those two numbers. 40 is where it starts on the bottom. 320 is where it starts on the top. We just need to make those go do this basic number here, and we'll be in pretty good shape. So let's do that. So let's say, let's create a variable called mouth openness. Okay? And let's start at something like 20. All right. So what I want to do here is I want to say, actually I just want to do mouth openness there. Okay? I'm going to make it go from 0 to 40 at the bottom, and then from 360 to 320 at the top. So here I'm going to say 320, excuse me, 360 minus mouth openness. So just to make sure we didn't break anything, we should see a slightly, let's see, I already broke something. I left a parentheses. Okay. This time, I'm putting this, and I mean it. All right. Third time's a charm. Okay, sweet. So now let's just animate it. So let's think about this. All right. So we're changing our direction over time. Let's do this. Let's do this. If thing dot mouth openness is greater than 40, equal to 40, all right? I want to have that start going down, all right? So how do I do the down? Well, here we go. You know how we have to get our direction before? Mouth direction. Let's just start with positive there. Okay, so if it's greater than 40, I need it to start going down. So I'm going to say this, nope, thing dot mouth direction equals 1. Okay. However, if thing dot mouth openness is equal to 0, less than or equal to 0, thing dot mouth direction equals 1. Okay? We good? All right, so that's just going to change that number. We're not finished. So we got to actually change that number. So what we can do is we can say thing dot mouth openness plus 1 times thing dot mouth direction. I think that might work. Any votes? This is the ultimate test. Yeah. All right. Okay, cool. So we have a Pac-Man that's now eating backwards half of the time. Let's change that. Actually, let's move on. If we have time, we'll come back to that. All right? I want to show you some other things. That shows you the basics of the Canvas API. Okay? I have another page for you. All right? Another incredibly well-designed page. That canvas is really big. All right. So here's what I want to show you. I want to show you how you would start. We talked about basic drawing. We talked about what you would do in animation. I want to talk to you about how you would build an application in Canvas. Okay? Now let's say you have a bunch of DOM nodes on a page. Right? You have a button here, and a button here, and a div there. All right? Even though you've clicked on a button or a div, what do? You attach an event handler to the thing, and that way you know that you wouldn't click on it. Right? Whenever you draw something in Canvas, it's just a bunch of pixels. Okay? You can't attach an event handler to a bunch of pixels on the screen. So if you want to do something like interactivity, like selecting something that you've drawn to the screen, or deselecting, or moving something on the screen, you have to do something completely different, 100% different than what you're going to do in normal HTML. Because you know what? That's not normal HTML. This is a canvas, and you're moving pixels around the screen, then deleting, drawing the pixel slightly somewhere else, deleting slightly somewhere else, and so on. Okay? And because I haven't said it before, this is a bitmap-based thing. There are no vectors here. This is just pixels on the screen. All right. So what do? Let's look at some more code. So I'm going to look at this page. Get to the file extensions. That's the wrong one. That's the wrong one. This is the one we want. Okay, this is that page. We've got some styling. The buttons and the control panel that has the buttons, and I have this border on the canvas. here's our canvas, and well, that's it for canvas. We have our buttons on the right-hand side, and down here I'm including all of my JavaScript files that do all the stuff that we're ultimately going to see. Okay. What we saw just now was a baseline. This would be, the starts of if you, for example, were going to make a sentence diagramming program. Okay. My first software project, first thing I built and shipped was a Greek sentence diagramming tool. So that's why I think in these terms. You probably are not very interested in that. Just think anything you'd want to draw. So this is the kind of thing that you would want to do. So all right, so that was the page. Now what are we going to do? Well, because this has lots of button events and lots of stuff going on, what I did next is then I broke out and I have a JavaScript file that's all about DOM events, and that's pretty much it. Getting the elements and DOM events. And so we've got the canvas, we've got the context, we've got our buttons, we've got clicking events. I have a drawing space. This is the thing that manages all the drawing. We'll be spending a lot of time there here in a second. And I'm also going to load an image. All right, this is an image entirely full of minotaurs. Because why wouldn't you want to have minotaurs in your presentation if you can? And it'll make sense. And then I have a function for getting the position whenever you click in there. All right. So while we're here, let's talk about the minotaurs. Minotaurs. Look at that. This is a sprite that we used 2 node knockouts ago in our game. We created a game called Minotaur Wars. It wasn't originally supposed to be Minotaurs. It was a 2-day hackathon, and you're like, we need a sprite just to make our game. It's basically an isometric chessboard. We need a sprite to make our game. We'll change it out later. We'll have plenty of time in the hackathon to put in there. And of course that didn't happen, and we were like, oh, forget it. We'll just use the sprite for the Minotaur. We changed the name of the project to fit the sprite that we had. It's a fantastic sprite. It's got him in various different positions, running, standing, or chopping with an axe. And so if you moved into someone's, by someone, you could chop them, and you had the animation of the axe, and then you had the animation of the Minotaur falling down dead to the ground. It's a good moment. All right, so that's the image that we're loading. Okay. Our drawing space. I have a draw loop. I mentioned earlier, we need a draw loop. Here we go. Window, request animation frame, draw loop. Okay? And there's an array of objects here, and anytime I click on this button, another object shows up. Like, for example, okay? Yo dog. So those all get added to this object array. And every time we draw, what do? We clear the rectangle, because we are, in a minute, going to be animating. And then we loop through all the objects, and we draw them. And this is really the key right there. Loop through all the objects and draw. Okay? Black and white. We'll get to that in a minute. Okay, so let's follow a click through. So we're going to be in here. We're going to click on the baseline button, which goes into here. Baseline button, which is right here. Whenever someone clicks, create a baseline. All right, pass the canvas context because it's going to need to know how to draw itself. The context is your brush. And I want it to be a 200 by 200, and that's why I showed up where it did. So baseline. What's going on with the baseline? Here it is. Okay. I like these little self-executing functions. It lets me pretend I'm not in a browser window, and I don't have access to global state. I do, but I'm just pretending. Baseline. I have a function here. It takes the context, the x and the y, and I'm going to set some settings on this guy. So down here I can do the drawing. And I'm inheriting from something called canvas object. Setting the prototype. This allows me to, this already has the functionality for drawing the selected state. When I click it, the little dashed lines, that was that. This will be so if I know I'm clicking on something, there you go. And then tell it to move to a location. Okay, so, and it has a draw function. So the baseline has a line across the horizontal. That's this one right here. It's just begin path, move to, line to, stroke. And then it's got this little vertical line. Begin path, just start a new one, move to, line to, stroke. Very simple. Draw selected state. If it is selected, then I'm going to draw little lines. Let's look at that. So selection, I'll show you that here in a minute. If it's selected, it's going to come in here and do this. Now, see this save and this restore? This is one of the awesome things about Canvas, right? Canvas essentially has, the context has global state, well, not global state, state for that context. So if you set the fill style to a color, or if you set the stroke style to a color, it will forever be that color unless you set it back, okay? This can be very annoying because at some point you set one of those properties and then later down the line something starts drawing weird and you're not sure how this happens. This is where save and restore are very interesting because you can say save the context as it is. So I'm going to begin a path, rect. I'm going to set the line dash for this, okay? And then I'm going to set the style, and then I want to do the stroke, and then I want to restore. And so what it will do is it will basically, here's your save game point. You go through that stuff, and this restores it back to where it was before, so you don't have to spend so much effort managing the state of this context object. It's fantastic. So a few things here. Line dash. This is interesting. If I do 4, let's see what this looks like. You got this little dash. It's actually evenly spaced. You have a dash that's essentially 4 pixels long, and a space that's 4 pixels long. You can actually change that to like 10 and 4, okay? And so you can actually control how the dashing works in Canvas. Very cool.
Can you set an offset so you can get the marching ants effect like in 30 comics?
I have no idea.
I will
Look that up. That sounds great. Stroke style. Before we were just using hex for your colors. You can also use RGBA. So if you want to throw in some alpha channel in this, you can actually do that as well as far as your styling for both stroking and for filling. So that's useful to know. Okay, so for the following our click, we have click on the button. It creates the baseline. It adds it to the objects. This array. This is the add object that happens. So it pushes it onto this array. And so then, whenever it goes through its draw loop, it will clear, and then we'll loop through all the objects, and it will, at this point, draw it. Okay? That's how that works. That's it on that. Vertical descender is a lot of the same. Basically works very similar. Word, let's look at that. So Word, because it's also going to have it as its prototype, that same object, I can click it and draw it, and drag it around, and all that kind of stuff. It just looks slightly different, and so this is just another piece of the Canvas API I wanted to show you. Fill style, I set the font, I want a 20 pixel serif font, and I say fill text, here's my yo dog, and then the location. Okay? Now I'm putting some extra Y in there. This is weird that it works this way, but okay. If I select this guy, okay, see the selection thing is below it. And the reason why is it draws at the X and Y as its bottom left-hand corner. Okay? It's kind of annoying. Wrong way again. So that's why I did the plus 20, plus 20. That's why I did this, so that the selection will be in the height and width and XY that I want.
And that's something I remember from once upon a time, like board C drawing text had the same weirdness.
I think, doesn't PDF start at the bottom corner, one of the bottom corners?
Yeah, I think PDF has similar weirdness to that. I've kind of gone up to.
For some reason, this has stopped working entirely. I blame myself. Okay, there it is. Okay. When am I getting any errors? Alright, so that's a word. Alright? Now, let's talk about animation. Okay, so why in this case? Because we're not technically animating anything. Alright? Why do we have to clear the context? Because every time I select and drag, I'm changing the XY coordinate of this guy. If I didn't, let's not clear context and see what happens. It's beautiful. So in this case, it's like I'm manually animating things, essentially. Oh yeah, that's what you ultimately get if you don't clear the context. So you gotta do that.
Mouse drop.
Yeah, it's almost like an old Windows book. Okay. Now let's talk about animation a little bit more. So we did Pac-Man, and we did Pac-Man just by drawing him and changing things. Often, whenever you're doing animation in a game or in any other case, you're not going to actually be drawing all the primitives on the screen. All right. It's often going to be a lot faster to actually take an image. All right. And that's what this Minotaur is. And for game animation, and I guess lots of others, if you want to make this thing, for example, look like it's animated, is you draw this one, then erase it, draw this one, erase it, draw this one, erase it, just like cartoons, right? Just like movie frames. Same exact concept here. And so here we've got our Minotaur, okay, walking across the screen. And that is this sprite, and I'm just going from this image to that image. And then when I get to the end, I start over. And then I have a Minotaur walking on my screen for some strange reason. And so I can do really strange things, like I can diagram my sentence, and I can actually have my Minotaur walking on my sentence. Not that it makes sense, but you can do it. That's why you use Canvas. Okay, so wrong way again. So let's talk about that sprite. So here's my sprite x coordinates. I already have my y. It's just one line. I have it hard coded. I think. Yes, I have it hard coded. So I have my y hard coded, and I'm just marching x coordinates across that PNG. So here we go. I am in this case doing a set interval because I don't want him to animate at 60 frames a second. That's going to be an incredibly fast moving Minotaur. All right, I don't want that. So I just created a set interval in this particular case, just the way I did it. To just work every 100 milliseconds, what I'm going to do is change my position. I'm going to walk up and down that array. So that, and that's when this change sprite position is called. So that whenever it comes to drawing, I pick the x position, here's your sprite x coordinates, and draw it. So let's this to where this is readable. Okay, so what's going on here? See the context, here's our C. We're drawing an image. This is an API that comes with Canvas, right? It has several different overloads. The one that I'm using is the one you would use if you're essentially doing animations on sprites, okay? So we say, okay, what is this? This dot sprite, this is the image. Okay, I loaded this up. I showed you that in the JavaScript file earlier. This is the image I loaded up. I passed it in. So I'm going to draw this particular image. Where do I need to go in that image? I need to go this x and this y. Okay. What's the size I need to pull from the image? What is the width and height? All right, I've got x and y. How much of that image do I want to take? That's this. I want to take 150 pixels square, both width and height. Now, where do I want to draw it on the canvas? This dot x, this dot y, and how big, width, and height. And so the actual the actual sprite size here is 150. But it's actually the width and height of 200 that I'm drawing it, which is why it looks ever so slightly greeny, because I'm drawing it a little bit bigger. So you can take it at one size and then draw it at a completely different size. Okay? There are much easier overloads. There's one where you pass in an image and you say an X and a Y and it just draws it there on the canvas. Okay? Now, remember when I said earlier you want to strive for 60 frames a second? Let's break that rule, all right? Hopefully the contrast here is good enough. Watch that Minotaur. He slowed down. because I slowed it. My logic is, there's too much logic to make this black and white. Color, black and white. Color, black and white. Okay. So I want to explain this, because this is another major and very cool application of Canvas. Oh my goodness. So if we go to our drawing space, all right? If we have black and white selected, where's draw? Here's my draw loop. Okay, if black and white is turned on, and I toggle that with that button click, I want to repaint the whole thing black and white. All right, let me show you why this is slow, but you'll still get the idea and see why it's cool, and then we'll talk about how you do it. Okay? All right. Canvas is a big thing of pixels. All right. So this is where this comes in very clear. Big thing of pixels. So what you can do with the canvas is you can say get image data on the context. Okay. Why it's not on the canvas, I actually don't know. To me, it would make more sense to have this on the canvas object, but it's actually more convenient in this case to have it on context because I'm not passing the canvas object around. But anyway, I say get image data, x and y of 0, so top left-hand corner, but the width of the entire canvas. Okay, so what this will do will give me an array. Okay, and it gives me an array. See, we're looping through this array in chunks of 4s. It gives me an array of integers. Okay, and the groups of 4, it's red, green, blue, alpha. Okay, and so if you want to take all the actual pixel data or all RGB data from a canvas and do something with it, whatever you want to do, you can take that out and change it. Now in this particular case, I'm changing everything to black and white. The lines didn't get affected, they were already black. The whites, there wasn't actually any data there, no effect. But the Minotaur, which wasn't just black or white, I get the red, green, blue for all of these. I average them together, and then assign that value to all the red, the green, and the blue. And then I put the image data back onto the canvas. We'll draw it back at 0, 0. And since it had the total data size of what it had, I don't have to specify width and height again. It'll just paint it right there. Okay? And that's how I turn the image black and white. Now, in a context like, let's say we're making a Minotaur game, you're not going to want to turn the entire screen to black and white. But, however, there are definitely lots of contexts that you would want to do this. My hackathon project at Match, we have hack weeks. We had one this year, we had one year before that, I don't remember how long was that. What's that?
13 and 14.
13, 14. Okay, so in 13, I created an in-the-browser image editor. Okay? Essentially what you could do is it loaded in a canvas a picture, a regular image, and this was for our users. Match, there's lots of photos. Lots of people don't have image editing software on their machine, or if they do, they may not even know it, or if they do know it, they may not know how to use it. So the idea would be, let's create an in-the-browser photo editor. So you could do some basic things in that. Black and white was one of the things I could do. Some people like to have black and white photos. So you take the image, and we did a number of things. Black and white, we did sepia, we did, you could change like the brightness, and I had to basically look up online algorithms for changing brightness and changing, like sharpening pictures and all this kind of stuff. You can find that. People have been doing this in JavaScript because they're crazy. And so I took those and put those in there. We also did things like cropping of the data. Because you can select whenever you get the image data, you could say, go to 50/50, and then get me a width of 50/50, and you're going to have a 50 by 50 pixel square of data. All right? And you can take that data and you can copy that into another canvas. Or you can take that data and you can send it server side and say, here's a bunch of pixel data, and you can save it on disk. Okay? So cropping. We did pixelation. So if you have a picture with your ex-girlfriend, and it's a great picture of you, but you don't want to post a picture of you with your ex-girlfriend on Match, or another, just a guy, and you're like, well, he's the handsome one, but I want them to focus on me. And so you use the pixelation tool, where you go through and you pixelate their face in the browser, and then you can save that. I thought that was a really good idea. Also, we did image rotation I don't remember what else we did. We did a number of things.
Yeah, you did an interactive brush with the alpha blending, so you could just do those effects as you drove them in sequence.
Oh yeah, that's true. Yeah, that was fun.
So these tools gonna be available if you're filling out your profile? Catch a free app.
I wish, because there was lots of people that liked it, and they were like, "This is a great project." I'm like, "Okay, let's launch it." And like, "Oh wait, we want to do this other thing that'll make money." Very disappointing. So they haven't launched it yet, though. They will sometimes bring it up to me. It's like, "Hey, Eric, we're gonna do in the browser photo editor this year." I'm like, "Great, I'll help you work on that," and then it just gets straight to you. So I liked it. I won the award for the biggest bug that year. There was some bug where if you rotated your iPad, because we tested this primarily on iPad and iPhone, if you rotated your iPad, it reapplied functions, and the chief architect of the company thought it'd be funny to give me the biggest bug award. So I got the biggest bug award, so I got something out of it anyway.
For
even if I don't
creating
get
the
feature.
biggest bug or for fixing the biggest bug?
Making it.
There you go.
But you can look at it this way. Our team had enough done to where we could have a big bug. We actually had something that was right. So you could do image editing. Like, now you turn an image black and white. Are you going to be animating that? Well, no. It's just a one-time pass through the data to do this kind of thing. And so it's going to be plenty fast. I mean, think about it. Look, see how fast that thing's moving? It's however many frames a second that is. Let's see. See how fast it's moving right there. It's taking all the data, averaging everything down to gray, and painting it back on. Ridiculously fast. Okay. So applications. Like a photo editor would be one. I don't have this sample. I wish I would have it. It's actually fairly easy, for example, to make a signature in the browser signature tool. All right. If you think about what we've done, how would you do this? All right. Well, you have a canvas on screen. That's obvious. Then what you do is you manage both touch and click events to get location. Okay. Then every time they move their finger, they put down the finger. You begin a path, and you draw a little line segment as they move. When they pick it up, and then put it down, they start a new path. So you're drawing on the canvas. You do it all, and then when you have a button there where they say, "Oh, I'm ready to save it," boom. It does what we did with black and white. It gets all of the data. I think what you do is you then base64 encode it, and then you send that to the server, and the server then can save that as any image format you want on the server. And there you've got, in a browser, signature capture. I thought that was pretty cool. We don't have a need for that at Mac, so that's not something we'll be launching there. I don't think we ever take signatures for anything. But I'm sure there's plenty of applications where you can have that kind of thing. Of course, games. So NodeKick. So
Wait, you haven't showed us how you figure out where the mouse is and what it's on to drag.
let's do that. Okay, thank you. Because that was went the wrong way again. That was kind of the point of this, right? So how do you do that? You don't have DOM elements. So what do you do? So let's start through this and say, okay, we need no, that's fine. All right, so here we go. So I have click on the main canvas, all right? Not any sub elements, on the canvas itself. I have click, mouse down, mouse move, and mouse up, okay? Those are my DOM events for doing all of this stuff. Okay, so those are mirrored by 4 functions in my drawing space, okay? Click will find an object. How do we know where the object is? I have a function called getObjectPoint. Okay, we get that object, and then we essentially mark it as the opposite of what it currently is in the selection state. So if it's undefined or false, it'll become true. If it's true, it'll become false. Okay, well, what about getObjectPoint? Well, getObjectPoint is down here. There it is. Okay, so I loop through all of the objects which are in my array. Okay, and all of them have a function called pointInBounds. I take the point that I clicked on, okay, I pass it in and say, is it in you? If it is, then I'm going to return that object from the getObjectPoint. If it is not in any of them, I return null. So then, going back with the click, so this passes the XY that I clicked on down in there into the array, goes through the entire array, finds what there is, pull it out, and we'll change the state. Okay, so what about mouse down? So on mouse down, I only want to start moving things that are already previously selected. So I'm going to get the object at that point, and if there is no object at this point, or there is an object, but it is not selected, I'm just going to return new nothing. Okay? So if I have found an object and it is selected, I will set the current moving object. I actually don't think I'm using this anymore. I will set the mouse offset, okay? Because what I want to do is whenever I select something, when I select something and I start moving it, I want it to always stay relative to where my mouse is, okay? I don't want, because if you basically say, oh, okay, well move this element to the current X and Y of my mouse, it will immediately jump where the top left-hand corner is exactly where my mouse is, and that is not at all what I want. So you have a little bit of offset math. So, okay, so let's see. I'm going to set that offset, and then I'm going to log something, which is not functional. Okay. Now on mouse move, if there is a currently moving object, and there would be, because I just put the mouse down, I'm going to move it to that location. Okay, so let's talk about move to. Move to takes in mind all of this offset garbage, and then changes their X and Y. Okay? So move changes the X and Y. Does that change it on the screen? No. That just changes the data representation. However, assuming I'm not turning anything black and white, this thing is firing 60 times a second. So I move the data. So the data is now changed. It will very quickly come through and loop through, well, clear everything, loop through, and at that loop, it will now be at the new location. Okay? So, it's kind of weird. If you're used to DOM elements and animating and doing this kind of stuff, this is completely different, as you can see. But it does kind of at least make sense, I hope. And then on mouse up, assuming I'm still over that object, and I probably don't need to do that check at this point, but whatever. I get rid of the mouse offset, so when I click on it next time, there won't be anything. And I set the currently moving object to null, and that is it. So I'm not animating, but I'm basically doing two things. Drawing all of the time, whatever the state of all of my objects are. And at other times, based on click events, just changing the X and Y, and it just appears as if when I move, that's moving the thing, and that's not actually true. It does not move pixels, it's just changing the data state. And then the draw loop just invalidates, clears everything and redraws it. So, yes?
In the simpler case of a signature, you could just use like the event, what is it, client X and client Y, to figure out where you are on the canvas if you're not maintaining your own objects, but you're just tracing a single path, something like that.
There's problems. There's a lot of cross-browser problems with finding your location within an element. There's actually I have a table in my book where I go through all of these. I have a book on mobile web development for ASP.NET EDC. And I have 2 chapters on touch events. And this is very important in the touch events because in there I actually do a signature capture walk through how you would build that in JavaScript with touch events in Canvas. So I went through, basically what I did to figure this out is I went through and had elements on a screen in various positions, like over from the left, far from the top. How does this work on Chrome, IE, Firefox, Android default browser, Android Chrome, and Safari? So I went through all of those and looked at those and said, okay, what acts the least weird? Okay? And the only way that works across all browsers that I could find was where's that function? There it is, skip position. All right? I get the page X and page Y and subtract the offset of the thing I'm actually picking. That will work, should work cross-browser. I haven't found any problems with So in some cases, yeah, you can just take mouse Y, you can take screen Y. What else is there? Page Y, screen Y, mouse Y. There's lots of different coordinates, and some browsers have some coordinates, and some others don't have those coordinates, but have other coordinates, because that makes sense. So this worked on all the browsers. And so you might, in some cases, be able to make it work just because if it's always at the top left-hand corner, that's easy. But if you're scrolling down a page and there's the element you need the position, then the offset is going to really mess you up in your Y position. Okay, so does that answer the question of how you do the clicking and how the drawing works and the state works? Right? You were changing the internal state and having a draw loop. All right? And as much as you can, has anybody done any sort of game development? Anybody? Okay. As much as you can, you're going to want to separate your drawing operations from your update operations. All right? You want draw to work as fast as possible can, and then have your update loop essentially doing other things. In this case, my update loop is just some mouse stuff. My drawing is just drawing. That's all it's doing. It clears and it draws. So it's really fast unless I'm repainting the whole thing black and white. So that's one thing you're going to want to do for smooth animations. Any questions around that? So that's how you do a canvas app. It's lots of drawing primitives. It's kind of cool. So let's look at this game. So I'll talk about some other things. I'm going to kill Mike here. I'm going to give him back. Have my sound on. Okay, so the way these worked is we actually had 3 sprites. Okay, excuse me, 3 images in each sprite. You've got, let's take my guy here. He's standing. I'm melee up here. Okay, he's standing. He's got a jumping position, and then he's got a kicking position. All right. But if you turn around, is standing, jumping, and kicking the other way. All right. So we didn't want to draw or borrow 6 images. We actually drew this one. This one we actually took from the dive kick game itself. They have images up online that you can just go download and play with. So we did that. We didn't make any money off of this, so we didn't feel bad about it. So we drew that one, but this one. So we didn't want to duplicate all these images. So what we did for all of these is we actually had an off-screen sprite. Okay, this is something you're going to do very commonly in games. And so if I wanted 6 ultimately images that I can, during animation, paste on the screen, because that's what you do, is I took this image, I then painted it reverse on another canvas, and got the image data. So then I had the raw image data for the image and the reversed image, and then whenever I'm moving, I'm not doing any procedural drawing, I'm just painting blobs of pixels. So it's very fast, okay?
You used a hidden canvas?
Yep. Yeah, they were just hidden in the DOM. Nobody could see them. There are all sorts of them in this game, but they're there. Another thing you can use these for is, let's say you want to combine the multiple pictures, or let's say you want to draw a bunch of circles and a bunch of lines and a bunch of squares and do a bunch of filling, and you want to draw procedurally like a spaceship for your game. Okay? Well, as you're animating that spaceship that has 200 drawing operations across the screen, okay, you don't want to try to 60 frames a second draw 200 drawing options. So what you can do is you can draw all those things to another canvas once, take the image data, and then as you animate across the screen, you're just drawing flopping pixels on the screen. Okay, that's all you're doing.
Because the math is more expensive than just dumping pixels. Is that what?
In some cases, it could be. In that case, it's if you're going to have 200 drawing operations of circles and lines and all that kind of stuff, you're actually telling context do that 200 times 60 times a second. When instead you can do it once, and you just have a blob of pixels, then you can say blob of pixels and have one canvas context operation 60 times a second.
Sort of analogous to copying and pasting a sentence once you've typed it once versus typing it.
Yes, thank you. Very good analogy. And so the way this game, essentially the way this works is, like I said, this is all canvas. This is a background, I think it's just a background image to the canvas. These are 2 different sprites, and we're doing exactly what I did on the game. on the little drawing thing we were just looking at a second ago. Whenever you jump, it starts doing calculations of where you should be, okay? And it's essentially it sends a command to the server, hey, malloc jumped, and so the server is pumping out the state over the WebSockets, okay, of what the game state is, very, very quickly, all right? And it's doing all of its calculations on the server so that you can't game the system, right? You can't say jump and move me to this position because it doesn't work that way. You just tell the game, hey, jump. It does its calculations on the server, and so it's just sending data to the client. And the draw loop on this is very simple. All it does the whole time is it says, what's my state? Draw that character. What's that character? What's his sprite? Get that sprite. Okay. What's his XY? Which way is he facing? Draw. So the draw loop on this is fairly simple. The other logic on the server side was not particularly simple, but that was actually fairly good, and we got really good performance on the client because of that. So anyway, that was one game. Minotaur Wars was same basic idea. It's you've got server-side state, and it's pumping it out to the client, and it's just when it sees someone has moved, it draws them there. Okay. When it sees that someone attacked, it says, okay, start your attacking animation, so it makes the Minotaur do this kind of thing. Okay. So that's Canvas. You've seen the basic API, you've seen some basic uses of it. The thing I like about it, and this is why it's my favorite HTML, is you can do anything with it. Anything that you know the math for, which is sometimes a problem for me, anything you know the math for, you can draw on that screen and do anything. Okay? That's why it's great for games or signature apps or photo apps or sentence diagramming. Yeah. Or anything you want to do. You can do all those things. So that's why I like it. And it's wrong way. The API isn't all that complicated, but you do have to be used to different techniques because if you're used to web programming, it's nothing like web programming at all. There's a DOM element on the screen, and that's it. It is all just, if you've ever done, anybody done iOS development? The Canvas API is very similar to the drawing API on iOS, and that would be because they created Canvas. They created the drawing API for it, so therefore it's going to look a lot like it.
Canvas API is familiar going back through some Java stuff and some C-related stuff. It's pretty, what ended up being a JavaScript API is pretty similar to what's been around for this type.
Good to know. The only custom drawing I've ever done, and I don't even remember how it worked, it was Windows Forms. I did some custom drawing. That was a while back. And, well, the original application, Authorware. It was awesome. You guys remember that from Macromedia? Mm-hmm. Authorware. That's what I planned on talking about today. Do you have any questions? Yes.
I want to ask you, when you mentioned about having your operation separate from drawing, updating, how does that improve your performance? Because JavaScript is basically single-threaded, and what's the benefit of separating these operations?
That's a good question. So in the case where, like in our Pac-Man example, there's actually, I'm not sure why that statement's worth saying, because in the Pac-Man example, we kind of have to do it. But in the mouse example, it is working on a different thread, essentially. It's working on your mouse movements, while the Canvas request animation frame is the browser's rendering. It's deciding when to call that. So you're not manually doing that. Now that being said, like the black and white thing, where you could still do it where it would make more sense. Like the black and white. Trying to change black and white 60 frames a second slowed the process down. If you can accomplish the same things you want to accomplish by not doing it 60 frames a second, but just doing a set interval where you do it 10 times a second. In that case, yeah, it's JavaScript on a single thread in the browser, yes, but you're not going to be doing it 60 frames a second. So in other words, don't tie, and this would be the way to say it, don't tie all of your updates to request animation Because if you can do it less, you will get much better rendering performance out of it. Yeah.
Maybe what Tinder, can I share an example?
Yes, please.
Okay, so on Match, we have a feature where you drag a photo to one side if you like, then the other side if you don't. And we got this working on much older Android mobile phones, and not to pick on Android, the early iOS phones were pretty slow too. So what we found is the user would drag around, and this would positionally change the coordinates of where the image would need to be drawn to show that photo coming this way or that at a higher rate than we could draw. So we would handle the touch events essentially in one thread, where we're calculating a new position, and then let the browser choose when to go ahead and draw the updates of when that was moving around based on when it could get around to it. And so that was an example where we're doing an update completely separately from when the browser decided to draw. We're just updating coordinates in a variable somewhere, mixing a couple of morph targets, and putting that in JavaScript memory, and then the request animation frame would draw that when it had time.
Now, there's a technique that I've heard of that I haven't tried. I've heard it from a number of people, so I'm assuming it's true. But one performance technique, and somebody correct me if they've tried this and it doesn't work, is one way to batch DOM updates and get credit for performance is to actually wrap them in request animation frame. Because if you have a bunch of DOM changes that you're making, you could be making those, and request animation frame is causing a redraw and all that kind of stuff. And instead, wrap them in a request animation frame, and it will actually do that as one atomic deal. I haven't ever tried it, something about it, but I don't know. That seems, on one hand, that seems kind of weird to me, but it's an interesting idea. Yes.
Yes, can you do 3D with the canvas?
If you want to do 3G, you're going to go WebGL.
Okay.
I know nothing about WebGL.
Okay.
You know who does?
Definitely, David over here. About 2 meetups back, there's a link to a talk David gave on WebGL.
Who's the?
But if you go back in our past meetups,
Okay.
there are links to his presentation and everything. So it's really good presentation.
At some point, I want to do WebGL, but math. Yes.
Is there like a canned sprite library for?
There's a lot of them.
I mean, that was my first introduction to computers, was logo and tell position, direction, speed, what shape to carry. It just went. And, that was great.
Yes, there are plenty of canvas-based frameworks for doing various things. My general approach to things is, I haven't actually tried many of them. On our last node knockout, Amir Rajan really wanted to do one, and I wouldn't let him. And then later he rewrote it with using one and said he liked it better. But anyway, my general approach to this is, I like to really understand it. And then, once I really understand it, okay, then I'll use a framework. Because if you don't do that, you get used to the framework, and you're like, I got this is easy. Then something bad happens, and you're like, I need to figure out why this library isn't working correctly. But I don't know anything about the underlying technology. I'm totally host.
Yeah, I've heard stories of like a Chrome update breaking something, and then you've got everything hung on this one thing that you can't fix.
So at that point, you can then just go and start learning the basics and working your way up. I just prefer not to work that way. Sometimes you have to, because you're using libraries that are huge and be really hard to understand. At work right now, I'm doing a lot with React. I do not understand the internals of React at all. If it doesn't work, I don't know what I'm going to do. Ask someone else, and then let them go. I don't know. I'll try to figure it out, but it's big, and complicated. Yeah. So you got to do it sometimes. Canvas, I like its API primitives low enough where I'm like, you know what? This I like dealing with, and sometimes you go, ooh, you got to do this weird technique to make this thing work with off-screen canvases and all this kind of stuff. But that's actually fun for me. If I was building an app based on Canvas with a team, where we have to have an ongoing app, well, that would be a different discussion. If it's just me, I'm just going to do raw Canvas just because I like it.
Can you show us some examples of some websites, production websites that are using this technology?
Yes. Nodekick.com.
Is that the only one?
I've seen demos. I've seen lots of demos. I don't honestly know how often it's used in production. I know it's used in game development on the web, right? Because Apple said no more Flash. We will not have Flash on our devices. And so for people to do HTML5 based games, either means moving DOM elements around, or doing SVG stuff, or Canvas. I think that's pretty much your only options.
A lot of dashboard charting uses Canvas, now, doesn't it?
That would totally make sense. Like, actually, a lot of dashboard charting would also make a lot of sense as SVG as well, right? But I could totally imagine creating a graphing library and doing Google Analytics in Canvas. I don't know what it actually uses. At work, we don't use it for anything on mobile, do we?
Unfortunately, no.
We don't actually use it for anything on mobile. So
At Match.com you don't use it?
we don't use it at all. I want to use it,
Yeah.
but I have some say there, but I don't get to just say, hey, I like Canvas, therefore we're going to use it for everything. I wish I could. I like Canvas. It is my favorite node. So games are a particularly useful thing, and those type of applications you could use it for. And it's got really good support. I think you get it. You don't get it in IE till like 9, I think, or 10. But hey, older IE is dying out pretty quickly. It has fantastic support on Android, even a lot of old Android. It has fantastic support on Safari, mobile Safari, real Safari, Chrome, Firefox. It has incredibly good browser support. But I don't know many, take that back, I don't know any in-browser game developers. And so therefore, I don't get to hear their horror stories. It makes me sad. Let's check out the, they've changed the design. There it is. Here's your browser support for Canvas. Opera Mini is apparently iffy in IA. Look at that support.
Wow, it's fantastic.
By the way, it's a great website. Can I use? That's a good question, though. It's one of those things where I don't think most web developers think about it, about solving problems, because it's so weird. It's so awesome, but it's so weird. Like the photo editor at Match, this totally makes sense to me. And it made sense to them as well. There's not a single product owner in our organization who would have ever thought of doing this, because how would they know about Canvas, right? So I think it's very much out, unless you're doing game development, unless you're doing custom drawing or pixel manipulation like that, and that's limited field outside of games, you're not even going to think about this.
Yeah, prior to coming in here, I did a search on sample Canvas apps or examples. There's probably 24 or so out there. Some of them are okay, some of them are not.
Really, really important one at tinyurl.com/Contra.
Is that still running? This is, okay, so, yes, Gauntlet in Contra. What's that?
It'll zoom in on it.
So this is something Mike made for me. I was making a game, because, well, why wouldn't you? I wanted essentially Gauntlet with Contra power-ups. So you're playing Gauntlet and you've got the spreader with your axe. That'd be awesome. So that's essentially what there was a, like an instructional day, Windows, over at Microsoft of how to do Windows 8 development with HTML and JavaScript. So I went to it, and this was my entry, is that day I made Contra.
You won the,
And I won, where did I win for that?
it's like a Surface or something.
I didn't win a Surface. Remember? Maybe. Oh, I won a Samsung tablet. Surface didn't exist yet, I don't think, at the time. Anyway, Mike was nice enough to make me this logo, and this is Canvas based. This is exactly, how would you do this in anything in HTML other than Canvas? Well, of course, why would you ever do anything like this? But because you can. That's
Maybe
what
these
it is.
messages.
Anyway, I wish more people would use it because that would give me more excuses. Any other questions? Yes.
So on the not key, when you say use a hidden canvas, is there like multiple canvas stacking each other? And if so, first question is, how do you detect collision on that? And second is, in the case where you have signatures and you have a capture and convert that to an image, how would you do that with the stacking canvas?
Okay, let's talk about the hidden canvas concept. So, I'll use the board. Apologies to people who are sitting over there. So the way it's essentially worked with NodeKick, and also we had to do the same thing with Minotaur Wars, which I really wish I had a screenshot for you. This is all we showed on the screen, and we had four different sprites, a red and a blue. No, we knew just three. The blue guy, the Ninja Turtle, and we had Heisenberg from XKCD. Those were our three sprites. And so we had three hidden. So these were all hidden to the browser, all right? Three canvases that had the flipped versions of these, okay? We also had some other canvases for some of the other effects that we were doing. Like, if I recall correctly, the one we launched with for whenever you kill someone, it actually made them fade out, if I recall correctly.
Yeah.
We did, is that right? This is a later one, Casey Foster, who works at WorkSync, changed and used another library to break people into pieces, because that's awesome. There was another canvas over here that we would, or series of canvases that we would use to start basically drawing things to and do multiple operations and do one single operation than here. Or in the case of the Minotaur one, all right? So it's an isometric grid where you got all this stuff. We had, actually, I think there's a screenshot on Amir's GitHub. GitHub Minotaur Wars. So Amir has been with me all my years of crazy node knockouting, and he doesn't have a screenshot.
But it's more images, right?
Yeah, there's some of the stuff in the background. This background, yes. Okay, so like for example, this was see these minotaurs? Those are actually, we took those sprites in Photoshop and then actually turned them into statues. This was the playing board right here in the middle. And so the grid, which was in this gray part, which isn't here, was drawn by Canvas, because that was really easy to do in Canvas to draw the grid. And so we did the same thing for it, where we took this PNG or JPEG. We took this JPEG and then put it on a canvas, not this canvas, over here. We drew all of that on it, then drew some other effects on it over here, then had that canvas pre-composed. Then, on the draw loop here, the Minotaurs are moving and doing things and all this kind of stuff. So basically with every request animation frame, it doesn't have to paint the image, then draw the squares. It's just got already the pre-rendered image where it just, I took the data, put it in a variable, and then just plop it on every time. Very, very, very fast operation. So this would be the example of why. Now, you don't have to worry about collisions because you don't actually take these canvases and like put them on here. You take the data from the canvases. You use what we did with the black and white, where you say, give me the data for either a portion of the canvas or for the entire canvas. Take that and then just plop that over here.
Is it even necessary to add the canvas elements, appending them to the DOM, or can you just deal with them entirely in JavaScript?
You can just build them in JavaScript and use them there. You don't actually have to have them. Now, one thing that's fun is whenever you do a lot of this image manipulation in memory, then before you do is you have to attach a bunch of handlers to image load events. So once all the images are loaded in the browser, at that point you can actually start drawing them and on these canvases, rendering them to what you want, then put them in memory, the data in memory that you use it as well. But anyway, that's how that works. So this was Minotaur Wars. There's a full screenshot. If you want to mess around with it, Amir Rajan has a source code of maybe not the final version. He's tweaked some of these things. For Minotaur Wars, he has let's see. Probably won't have a conquest one, but he will have node kick. So if you want to look on there, if you want to see how node works, WebSockets, all that kind of stuff, you can check that out. I tried to get node kick running, and one of the npm dependencies was causing issues, so I need to figure out what that is. But anyway, if you want to look through the code, you can. What else?
Do you have to manage drawing order? So, you know, if something gets, so I mean, you just had a draw loop that was looping through your set of objects,
Yep.
right? Do you put them into that array in a specified order?
You have to manage your drawing operations, and the reason why is it's just pixels, right? If let's say you draw a circle here, then you draw a line through the circle, okay? The circle is not maintained on the canvas. The circle is not maintained. It's just, it draws the pixels, and they're just pixels. You draw the line on top of it. Those pixels that were under the line are now overwritten by the line. You know, there's pixels in the circle. And so if you want the circle to be in front of the image, you absolutely have to, because it's essentially going to, by default, last in wins, the last pixel written. Now, that doesn't have to be that way. There's Canvas.
Like a XOR operation of the brush or something?
They have now a few different modes.
There's a surprising number of modes. I've used them very rarely, but it's still pretty cool. Like you can do combination. You can set like alpha over the whole canvas for a while, and so everything you draw in alpha. You can say the opposite, where whatever is written first stays on top, and everything gets drawn under it. There's a number of things, and I don't actually remember the name of the particular API for doing that, and that's why I'm actually Googling for it. Like I said, it's not something I do much. And there's lots of actually really good tutorials about Canvas out there. This is not what I need at all. So that is controllable. So one book, if you want a good book on Canvas. This is the one I like the most. So, and a lot of these, and there's multiple books on HTML5 Canvas. There's plenty of material on the web. There's plenty of books about it. This thing has been around for a long time. It's all the support, right? It's been around plenty long. There's plenty of books. There's lots of material. There's lots of samples out there. It's the only difficulties I have on Canvas are always math related. Really, I've got several different books on math. Because I did not do particularly well in high school, and did even worse in college. I did not do a computer science degree, where I would have had to do a lot more. So it's always been a weak point of mine. So at some point, I have to go back to it. I want to remake my diagramming app at some point, and to do that, it's going to involve a lot of 2D math. So yeah, so that's where I have no problems. The Canvas API, it has lots of features, but you do 95% of what you want to do with just a small handful of features. Anything else? Okay. Are you welcome? If you want to get in touch with me, you can tweet me. Oh, you can also email me if you want to. So, Or you can email me, Matt, just Eric Sowell. I'll let you do that. If you are looking for a job, I would love to get a referral bonus off of you, so you can email me. Matt's just good referral bonuses.